This is the first in a series of videos about hypothesis tests. And this is the easiest one in an exam situation. So a basketball player has taken tens of thousands of shots, hundreds of thousands. And in the future, he'll take many, many more. So this is a population. And you should think of a population as something that we can't really access. We don't know in the future how well he'll shoot. And so the population is kind of inaccessible. And so if we want to study it, we have to take a sample. Now, he wants to know if the distance to the basket is correlated to the success of each shot. Surely it is. If you're closer, surely that will raise your chances. So what we're going to do is imagine he's taken 20 shots from every possible distance and angle, every possible distance, hundreds of thousands of experiments. Just imagine he did that. What would we get? We would get a population. This is, if he shoots from 2.43 meters away, he'll get 18 out of 20. If he shot from 12.82 away, he'll only get 1.22 out of 20 on average. Now, I'm imagining there is an almost infinite number of these in my population, every conceivable distance to every accuracy, hundreds and hundreds of thousands of pairings of numbers. And the question is, are they correlated? Is the distance away, 18, correlated? The distance away, 2.43, is it correlated to the amount of success out of 20? It certainly looks it, in that if we're nearby, he's getting a high score out of 20. If we're further away, he's getting a low score. But there's some anomalies, as you'd expect. So think of the population. Now, what is the correlation of all of these numbers? Well, we don't know. How could we possibly know? We don't even have all the data. There's hundreds of thousands of them, and I've only listed 6. So what we say is the correlation coefficient is just called, this is a Greek symbol rho, which is the Greek symbol for the letter R. R is the traditional symbol of correlation. And the reason it's in Greek is to kind of make it mysterious, to say we never know what the parameters of a population are. Okay, but that's exactly what this guy is claiming. He says, we're trying to say, are these numbers correlated? How do you work out if these were correlated? Well, I hope you just said, oh, let's take a sample. So what we've done is we've got him to go from 10 different distances and shoot 20 balls. And look, if he's only 2 meters away, he gets 17 out of 20. But if he's 6.2 meters away, he only gets 5 out of 20. So this is a sample. It's only got 10 distances in it, compared to this, which has got hundreds and hundreds of thousands of different distances in it. So the sample is a very small version of the population. And the big difference is we actually can measure the correlation between these two numbers dead easily. And so this is labeled R. So if you're talking about a sample, you use English letters. If you're talking about a population, use Greek letters. And you remember we're doing that because we can't know them. We can't know this. That's why we take a sample. Rho here is called a parameter. It's an unknown property of this population. R is known. I can easily calculate. Let's just do that straight away. So I've typed my data into menu 2, typed it in, and the nicest way to find it is you press graph, and then the first graph is built in to be a scatter graph. Let's have a look at the data. Oh yeah, it looks nicely correlated. And then you press F1 again, and it's saying, well, what sort of correlation do you want? Y equals mx plus c, or maybe squared or cubed? The only one we study is straight line correlation. So let's do that. It rather boringly asks you, do you want y equals mx plus c or c plus mx? So let's use that one. Now, I'm only interested in this number here. R, that is the correlation coefficient of my sample, is negative 0.9. They're pretty correlated. Let's draw the line of regression. There it is. So it looks correlated, and the correlation coefficient was negative 0.9. Negative because the closer you are, the more likely to succeed you are. So does that prove what we're trying to prove. Does that prove that our population is correlated? No, it doesn't, because we only took a sample of 10. Maybe he just had a good day on the short ones. Maybe he was really unlucky on this one, and he only got 8, but he hit the rim 12 times. I mean, it's just really unlucky. So a sample cannot ever capture the whole population, and this is why we have hypothesis testing. So the first thing you always do with a hypothesis test in an exam is to identify it. There are 9. Four of them are called t-tests. And a t-test simply means we don't know what the population standard deviation is. Why would we? So almost everything is a t-test. Chi-squared tests are very distinctive. I'll come to those. There's a strange one called a z-test. That is the situation where we do know the sample deviation. And there's only one of those called one sample. And then there's binomial and Poisson. So there's 9. And now this question, I think, is very clearly about correlation. Correlation is another word for regression. So this is quite an easy one to spot. We're going to do a t-test for regression. So the first decision is, what is the significance level? And I put 5%. This will be given you in the question. This is saying, how much doubt are we going to is acceptable? I want to say, yes, the sample data does show that distance is negatively correlated to success. The closer you are, the more successful you are. And so distance is negatively correlated to success. And I've got 5% doubt about that, because I know ultimately I took a sample, and that sample may have been lucky or unlucky. I don't really know, but I'm going to tolerate 5% doubt. Another way of saying that is 95% confidence. I can say that they are negatively correlated. Next, in all hypothesis tests, we have a null hypothesis, which is like the kind of the default position. And this is a statement made about the population. So we're saying the default position is that there is no correlation between the distance you are from the ring and whether you're successful or not. And that's the default position. What you're saying is, do an experiment, get a sample, and tell me I'm wrong. Tell me that this null hypothesis is wrong. Provide some evidence it's wrong. So if your null hypothesis is wrong, then it must be true that the alternative hypothesis is wrong. So the alternative is opposed to the null. The null is saying there's no correlation. And this is normally the claim being made. The claim in this question is, we think it's going to be negatively correlated. The closer you are, the distance is smaller, the success is bigger. So that's going to be my alternative. And you can get away with writing them in words, but good students don't. They write them in symbols. So these are, the null hypothesis is always the same in every regression hypothesis test. We're saying there is no correlation. Remember, this is the, can you remember what that symbol is? That is rho, and it is the correlation coefficient of the entire population. So I'm making a claim that there is just no correlation between distance and success in the population. And my alternative is, I think that it will be negatively correlated. It kind of makes sense for it to be negatively correlated, but I must provide evidence that this is true. So a hypothesis test is saying, is there enough evidence to reject H0? That is the whole thing a hypothesis test is. Is there enough evidence to reject H0? So in this case, we simply put it into the calculator. I'm just going to go back to this screen. Typed into the calculator, and I go, here's test. We have all 3 of these. Chi-squared tests are very distinctive. There is only one z-test, and that's very distinctive. So mostly you're pressing T. We do 1 sample, 2 sample, and regression. This is clearly regression. And then the only thing you have to adjust is this top one here, which is saying, what is your alternative hypothesis? Why doesn't it ask for the null hypothesis? Can you answer that? Well, the answer is because the null hypothesis is always the same. It's always that. So this is saying the alternative hypothesis, the claim being made is that we think it's negative correlation. So I put that in by pressing these buttons. I've obviously got the X list in this one, the Y list in list 2. I've already typed that in. So I now just run it. I just simply run it. And it tells me a p-value, a t-value, and a number of degrees of freedom. You must write all of these 3 things down. Using the degrees of freedom and the t-value, the calculator calculates the p-value. So I literally just copy this down. The degrees of freedom is 8. There were 10 bits of data, and so the degrees of freedom is 8. This is something you just have to learn, except the calculator simply tells it you. But for a regression hypothesis test, the number of degrees of freedom is by this formula here. So there are 8 degrees of freedom. I'll have a separate video about what that means. The t-value is -6, separate video about what that means. This is the important one. The p-value is this number here, slightly awkward number on the calculator. I've multiplied that by 100 to turn it into a percentage. This is a probability. This is a percentage. But because my significance level is 5%, I want to make sure I'm comparing like with the like. So the p-value is, what is the probability that the null hypothesis is correct? What is the probability that there is no correlation? Well, given that sample that we took, given the sample, the probability is tiny that this is correct. So what do we do? What we do is we say, because the probability is less than our agreed threshold of 5% doubt, I'm going to reject the null hypothesis. So you write it like this. This is our evidence here. The p-value, which is a probability that the null hypothesis is correct, is less than the 5% we agreed at the start of the question. Therefore, that means the null hypothesis is really unlikely, so I'm going to reject it. I reject the null hypothesis. That's the end of the hypothesis test. And you simply then cast it into the language of, what are they talking about? Oh, this one's about basketball. So you say there is sufficient evidence to suggest that distance is negatively correlated to success. And that is true of the whole population, not just our sample. Okay,